There is a point inside every black hole where physics commits suicide, not metaphorically, literally. The equations that govern everything, the orbit of planets, the chemistry of your blood, the rotation of every galaxy, reach a place where they stop producing answers and start producing the mathematical symbol for infinity. Infinity is not a number. Infinity is what physicists write down when they have officially run out of ideas. For a century, we told ourselves the same comforting sentence: we just need a better theory. One day, someone would crack open the singularity, fix the math, and put the universe back together. But over the last decade, that comfort has been quietly evaporating, because the more we observe real black holes, the more we realize the problem is worse than anyone admitted. Black holes aren't just breaking the rules at their center, they are breaking them everywhere. At their edges, in our galaxies, in the deep early universe, in the very definition of what existence is allowed to mean. What follows are 9 of them, and by the time we reach number 1, the foundation of modern physics will be standing at the edge of a cliff. Number 9. Time itself surrenders. Stand far enough away from a black hole, and you can watch something genuinely terrifying happen to a friend who falls in. You see them accelerate, you see them stretch, and then, just before they cross the event horizon, that invisible boundary from which nothing escapes, you see them freeze. Not metaphorically, they simply stop. Their image holds in place, reddening, dimming, suspended in a moment that for them lasts only a heartbeat, but for you, the outside observer, will last forever. From the falling person's perspective, they cross the horizon in seconds. From yours, they never cross at all. They become a photograph plastered against the side of the universe. This isn't science fiction. It is gravitational time dilation, predicted exactly by Einstein in 1915 and confirmed every time a clock on the International Space Station is compared to one on the ground. But near a black hole, the effect is no longer a tiny correction. It is total. Time, the thing we treat as a constant, the thing your watch is supposed to measure, becomes a variable that can be slowed, stretched, and at the event horizon itself, brought to a standstill. Two people in the same universe, watching the same event, will permanently disagree on whether it happened. There is no third observer who can resolve the disagreement. Both of them are correct. Reality itself has split in two, and we have not yet even reached the inside. Number 8. The ones that are too big to exist. In the constellation Canes Venatici, more than 10 billion light years from Earth, a quasar called TON 618 hides a heart of pure shadow. The black hole at its center has a mass of roughly 66 billion sun. Read that again. 66 billion, not million, billion. Our sun is, by any human measure, an unfathomable object. It contains 99.86% of all the mass in our solar system. You could fit 1.3 million Earths inside it, and TON 618's black hole equals 66 billion of those. There is a problem with this, a real mathematical, unsolved problem. The standard theory says black holes grow by eating gas and merging with other black holes. We know roughly how fast they can do this. There is even a physical limit called the Eddington limit that caps the rate at which a black hole can pull in matter before its own radiation pressure pushes the food away. Run the numbers for the age of the universe, 13.8 billion years, and the answer comes back simple and brutal. TON 618 should not exist. There has not been enough time, and TON 618 is not alone. Phoenix A is suspected to clock in around 100 billion solar masses. Several others lurk in the same impossible weight class. Each one is a clock that runs backward. Each one is the universe shrugging and quietly telling us that something, perhaps black holes, that formed directly from collapsing primordial gas. Perhaps mechanisms we have not yet imagined. We do not know what that something is. Number 7. The ones that existed before they should have. In July of 2022, the James Webb Space Telescope opened its golden eye and began staring at the oldest light in the universe. It immediately found a problem. Within its first year of observations, JWST detected supermassive black hole, millions of times the mass of our sun, sitting inside galaxies that existed only 400 to 500 million years after the Big Bang. In cosmic terms, this is the equivalent of a newborn baby walking into a hospital room already holding a steady job. Modern cosmology says galaxies should still have been forming at that age. Stars should have only just been igniting. The first black hole born from the deaths of the first generation of massive stars should still have been small, perhaps tens or hundreds of solar masses. To grow into the supermassive monsters we see today would require billions more years of feeding. And yet, there they are, already grown, already feeding, already running their galaxies. Physicists are now whispering a heretical word, primordial, the idea that maybe, just maybe, some black holes were not born from dying stars at all. Maybe they crystallized directly out of the hot soup of the Big Bang itself, ready-made, monstrous from birth. If that is true, every textbook ever written on stellar evolution needs a new chapter, and the universe gets older, weirder, and more populated with shadow objects than anyone dared admit. The light we see when we look across the cosmos is not the only thing being delivered to our telescopes. Something else, something darker, has been there the entire time, watching the universe grow up around it. Number 6. The wandering ghosts between the stars. For most of the history of astronomy, we assumed black holes sit politely at the centers of galaxies. The supermassive ones anchor their host like jewels in a crown. The smaller ones drift through stellar neighborhoods, everything in its place. Then, in 2022, the Hubble Space Telescope caught one walking, a stellar mass black hole, about 7 times the mass of our sun, completely alone, drifting through the constellation Sagittarius at roughly 100,000 miles per hour. No companion star, no glowing accretion disk to give it away. The only reason we found it at all is because it briefly passed in front of a distant background star, and its monstrous gravity bent the starlight in a precise, predicted way. Gravitational microlensing, the only fingerprint a true ghost can leave behind. This was the first isolated, free-floating black hole ever directly detected, and it raised a sickening implication. If one exists, there are millions. Astrophysicists estimate that the Milky Way alone contains roughly 100 million stellar mass black holes that are not attached to a companion. Most of them are invisible. Most of them will pass within light years of our solar system over the course of cosmic history, and we will never know. They are out there right now, silently sweeping through the dark spaces between stars, swallowing the occasional asteroid, occasionally bending light, and otherwise leaving no trace. The universe is not what we thought it was. The universe is haunted, and our maps of it, the careful charts of constellations and nebulae, are nothing more than the well-lit surface of a much darker, much fuller, much more crowded room. Number 5. The merger that should never have been possible. On May 21st, 2019, the LIGO and Virgo gravitational wave detector picked up a signal lasting 1/10 of a second. That signal was the death scream of 2 black holes spiraling into each other billions of light years away. The collision released in that single fraction of a second more energy than every star in the observable universe combined produced in the same moment. And the math of that collision broke physics. The two black holes that merged had masses of roughly 66 and 85 solar masses. The remnant they formed was 142, numbers that on paper look perfectly ordinary, except for one detail. According to every model of how stars die, black holes in that mass range between roughly 65 and 130 solar masses cannot exist at all. The reason is something called pair instability supernova. When a star this massive starts to die, the conditions in its core become so extreme that pairs of subatomic particles spontaneously appear out of pure energy. The star, in essence, eats itself from the inside, and instead of collapsing into a black hole, blows itself completely apart, leaving nothing behind. Stars in this mass range should leave no remnant. Not zero. The mass gap is real, and it is predicted by some of the most rigorously tested physics we have. And yet, two black holes inside that forbidden gap collided 7 billion years ago and produced one even further inside it. There are theories. Perhaps these were second-generation black holes, the merged remnants of even earlier mergers. Perhaps they formed from direct gas collapse. Perhaps a process we have not yet discovered exists. What is not theory is the recording. Something is producing black holes that the laws of stellar evolution insist should not exist, and it is doing it often enough for us to catch it. Number 4, they are not actually black. In 1974, a 32-year-old physicist named Stephen Hawking did the unthinkable. He combined Einstein's general relativity with the quantum mechanics of empty space, applied the result to a black hole, and got an answer no one wanted. Black holes are not black. They glow. They emit a faint thermal radiation from just outside their event horizon. Slowly, painfully slowly, they lose mass to this radiation, and eventually, after a length of time that is laughably greater than the current age of the universe, every black hole evaporates completely. This sounds like a beautiful, elegant result, a graceful death for the most violent objects in nature. It is not. It is a catastrophe. The reason it is a catastrophe is because of what happens to the information that fell in. Everything in physics, every particle, every collision, every chemical reaction, every neuron firing in your brain right now operates on a single foundational principle. Information cannot be destroyed. The state of the universe at this moment must, in principle, be recoverable from its state at any future moment. Cause and effect depend on it. Determinism depends on it. The very idea of physics as a predictive science depends on it. But Hawking's calculations said the radiation streaming off a black hole is purely thermal. It carries no detail about what fell in. A library swallowed by a black hole and an equivalent mass of hydrogen swallowed by a black hole produce exactly the same evaporation pattern. The library is gone, not stored, not encoded, erased. The universe, in other words, has a built-in shredder. For 50 years, physicists have been trying to disprove this. They have failed. The problem has a name, the black hole information paradox, and it haunts the entire field. We will return to it. Number 3, the firewall. In 2012, 4 physicists published a paper that, in the careful language of academic theoretical physics, can only be described as a screen. The paper argued that one of the deepest assumptions about black holes, Einstein's equivalence principle, the foundation stone of general relativity, must be wrong, or quantum mechanics must be wrong. There is no third option. The argument, called the Amps paradox after its author, sets up a thought experiment. Imagine an astronaut crossing the event horizon of an old black hole, one that has been evaporating for a long time. According to general relativity, the astronaut should feel nothing. The event horizon is not a wall. It is just an imaginary surface in empty space. Einstein himself promised that any sufficiently small observer in free fall feels no gravity at all. But the mathematics of quantum entanglement applied to Hawking's radiation says something completely different. It says the astronaut should hit at the precise moment of crossing the horizon a wall of pure energy hot enough to instantly incinerate a firewall. Both predictions cannot be true, yet both are derived from physical principles we have tested to extraordinary precision in every other context. One of them, perhaps both of them, is lying to us about what happens at the edge of a black hole. We do not know which. We do not know how to find out, and the existence of this paradox mean that some of the most successful theories in the history of science are quietly incompatible. Whenever a black hole is involved, they contradict each other. They cannot both describe reality, and we still have not figured out which one to trust. The universe is forcing us to choose, and the universe is not telling us how. Number two, reality is a hologram. The more closely physicists studied the surfaces of black holes, the stranger those surfaces became. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered that a black hole's entropy, a measure of its information content, is proportional not to its volume, but to its surface area. By the 1990s, physicists Leonard Susskind and Gerard T. Hooft realized this oddity was not a quirk of black holes. It was a clue about reality itself. They proposed something called the Holographic Principle. It states that all the information contained in any three-dimensional volume of space, every atom, every interaction, every memory inside your head, can be fully encoded on the two-dimensional boundaries surrounding the universe you are experiencing right now. The depth, the texture, the three-dimensional solidity of the room around you may be an emergent illusion. The fundamental screen on which reality is rendered may be a two-dimensional sheet, and what you call three-dimension may be a kind of mathematical interpretation we evolved to perceive. This is not philosophy. This is mainstream theoretical physics. The holographic principle has been confirmed mathematically in simplified model universe called anti-de Sitter spaces, where it works flawlessly. It is one of the most beautiful and disturbing ideas ever derived from physical equations, and it was derived from staring at black holes. The places we thought were holes in reality may have been telling us the entire time what reality actually is. Number one, the information has to go somewhere. We return now to the paradox we left waiting at number four. When a black hole evaporates completely, what happens to everything that fell in? This is the most important unanswered question in physics. It is more fundamental than dark matter, more fundamental than the origin of the Big Bang, because the answer determines whether the universe, at its deepest level, is a predictable system governed by knowable laws, or a casino in which information can simply cease to exist. If Hawking was right in 1974, the answer is annihilation. Everything that ever fell into a black hole, every star, every planet, every civilization unlucky enough to drift too close, is reduced over an unimaginable span of time into a featureless drizzle of radiation. The universe forgets forever. But in 2019 and 2020, a group of physicists using a new mathematical technique called the replica trick proved that no, the information must come back out. It is hidden inside the radiation, woven into subtle correlations between particles emitted billions of years apart. The book that fell in is in principle, still there, atomized, written in a code we do not know how to read. This is comforting until you ask the next question. How, by what physical mechanism, does the information escape? The event horizon, according to Einstein, is a one-way membrane. Nothing inside can ever influence anything outside. And yet, somehow, the information must be making it out. Nobody knows how. The leading candidates involve quantum entanglement, linking the inside of the black hole to its evaporation, a process Juan Maldacena and Leonard Susskind summarized in a single conjecture, ER equals EPR, that suggests wormholes and entanglement are the same thing. If true, the inside of every black hole is connected by a network of invisible bridges to the outside. The geometry of space itself becomes a kind of hidden communication network. We are no longer doing astronomy. We are no longer even doing physics in the classical sense. We are standing at the place where the universe stops being a thing you describe and starts being a thing you decode. This is where black holes leave us, not as exotic objects floating in distant galaxies, but as the cracks in the picture, the places where the most successful intellectual project in human history, the centuries-long effort to write the universe in the language of mathematics, meets equations that fight back. Time freezes. Mass appears where it cannot have form. Holes evaporate. Information escapes through one-way doors. The very dimensions of space dissolve into surfaces. Code, hologram. Every one of the 9 objects in this list is real. Every one has been observed, calculated, or rigorously derived from theories we have no reason to abandon. And yet, taken together, they suggest something the people who built modern physics never quite wanted to admit out loud. We are not standing at the end of a beautiful theory. We are standing at the beginning of a new one, and we have not yet learned its language. Somewhere in the data we already have, the next Einstein is waiting. The universe is not breaking. We are. And the silence on the other side of the event horizon is not empty. It is patient.